Greetings to all of our friends around the world and welcome once again to Kourou, the home of the Ariane family, for today's live broadcast of Arianespace flight number 233. The mission today, launch of more satellites for Europe's satellite positioning system called Galileo. All is green and go for the moment. To get us underway, some opening words from Arianespace Chairman Stéphane Israël.
Mesdames et messieurs, ladies and gentlemen, dear customers and partners, Arianespace is delighted to welcome you from the Guiana Space Center for this new Ariane 5 mission, which is the sixth of the year with our heavyweight vehicle. After a tremendous qualification work achieved by all partners, we are going to use for the first time our Ariane 5 ES version to launch 4 more Galileo satellites for the European Commission in the framework of a contract signed with the European Space Agency. The 4 satellites have been manufactured by OHB. Thanks to EC and ESA for your trust. As you can see on the control screen behind me, Ariane 5 is on the launch pad after having been transferred successfully 2 days ago. All the operations linked to the final countdown went well. So, we should be in a position to launch in a few minutes at exactly 10:06 and 48 seconds. It's not done yet, we have final operations to do, but we should be in this position. As you know, the liftoff occurs 7 seconds after the H0 with the ignition of the 2 solid boosters. Ariane 5 will then head towards the northeast to separate the 4 satellites 2 by 2 in a circular medium Earth orbit at an altitude of 22,900 kilometers, inclined at 55 degrees with respect to the equatorial plane. This mission will be long. You all need to be patient. 2 Galileo satellites will be first separated at H0 plus 3 hours and 36 minutes. And then the 2 last Galileo satellites will then be separated at H0 plus 3 hours and 56 minutes, marking the end of the mission. Our launch is now just a few minutes away. So go Ariane 5, go Galileo, go United Europe for space, and of course, enjoy the show. Thank you.
Joshua Jampol here. Our stage is set, the launcher ready to go, liftoff due in just a quarter of an hour, the 9th of the year for Arianespace. Our launch today for the European condition under a contract with the European Space Agency, and we'll be hearing now from John Werner, Director General of ESA.
Dear representatives of the European Commission, ladies and gentlemen, welcome to Kourou, the European Spaceport. Unfortunately, I cannot be with you today. But I'm witnessing this very important event, the first launch of Galileo satellites with an Ariane 5. 4 satellites in one launch, this is a premiere for us. Galileo is of course a flagship program for the European Commission as well as for us, the European Space Agency. Galileo is an instrument which brings satellite navigation to Europe but also to the world. And it's part of the joint statement we signed some weeks ago in Brussels between the European Commission and the European Space Agency. Galileo is for us more than just some activity in space together. It is a service which we bring to the society, to industry, as well as to individual citizens. And with these 4 satellites, in addition, we will have 18 satellites which can work on an operational basis for the satellite navigation. And also we will very soon announce what we call the initial services, meaning that we provide the data and the access to the satellites for industry and users. So I hope that we will have a successful launch today. I wish all of you a nice time in Kourou, and I hope to see you soon again. Thank you very much.
This version of the launcher is called the Ariane 5 ES, and it's used for sending payloads into low Earth orbit. The other version, the Ariane 5 ECA, it's called, mainly for commercial launches and used more often, and you may be more familiar with that Ariane 5, having seen a launch already yourself, perhaps. We want to introduce you to some of the key players and make the mission happen. This is the Arianespace High Command. Louis Laurent, the Senior VP for Programs. He'll be alongside Stéphane Israël, Chairman and Chief Executive, taking his seat after his opening words. And with these two gentlemen, Roland Lagier, the Chief Technical Officer. This is Arianespace top management, and these gentlemen make the call on anything that unexpected that comes up, either before or during the mission. We're coming to you live, as always, from the Jupiter Mission Control Center in the space base. Ariane 5 stands 50 meters tall, weighs 760 tons fully loaded. That means with passengers and the fuel. She's in two parts. There's a lower composite and the upper one. The lower including the core stage and the boosters, as you saw, and the upper component, the reignitable version of the upper stage, and the fairing inside of which are the two satellites. Up next, a look at the launch with Arianespace's Thierry Faem.
This launch will be performed with an Ariane 5 ES version, already used for ATV missions. This launcher is composed in particular of an EPS upper stage, which is different from the commercial Ariane 5 ECA version. The EPS storable propellant upper stage is powered by a reignitable engine that operates with MMH and N2O4 propellants, allowing reignition capabilities essential for required Galileo mission performance. A specific dispenser has been designed by Airbus Defence and Space, allowing to support a satellite maximal mass of 738 kg each. This dispenser is made from a combination of metal and composite materials for maximum stiffness, and it has undergone very comprehensive testing at Airbus Defence and Space premises located near Bordeaux.
The Galileo program, funded by the European Union, it's a new global satellite navigation system which will guarantee European independence in this area, and Arianespace very proud to play a part. As is so often the case with Arianespace, there's something new with this launch, several things, in fact. Those of you familiar with the Galileo program know we usually launch with a Soyuz. Well, as you can see, Soyuz has been replaced by Ariane 5, taking that role. And if you've been following the Galileo program, you will also recall that we launch in pairs, that is, 2 per launch. And you've also noticed that we're launching not 2 but 4 satellites on the mission today. With Ariane 5, we can lift about 7 times the weight that Soyuz can, so we're taking full advantage of that power. And of course, since it's the first time we're launching 4 Galileos, design a new about that later on. For the moment, take a look at a short film on the launcher campaign.
As usual, after an 11-day trip via the Atlantic Ocean, the Ariane 5 launch vehicle elements arrived by ship in Kourou Pariacabo Harbor.
The launch vehicle preparation campaign, like all the other ones, began by the unloading of the first stage, the EPC, the cryogenic central core. Next step is to transfer the solid rocket boosters, the EAP, from the storage building to the preparation building. After integration on the launch table, the main core is mated to the boosters. Till that point, the operations are the same as for the other Ariane 5 versions. The main characteristic of this Ariane 5 ES Galileo launcher is in the upper part before integrating the payload. This upper part is equipped with a vehicle equipment bay that is integrated directly into the EPC. The storable propellant stage is directly integrated into the VEB. The fueling is conducted in the final assembly building, where the VEB is first filled with hydrazine. Then the EPS is filled with MMH and N2O4 before final pressurization of the helium spheres at 400 bar. On the pneumatic and fluid side, the EPS and the VEB are ready to enter the automatic sequence.
The satellites campaign began early September with the arrival of the 4 spacecraft by cargo plane at Félix-Éboué Airport.
After
transferal of the satellites to the European Spaceport, the first operation was the fit check between the satellite and the dispenser. This is to verify the mechanical compatibility between the spacecraft and the launcher. Everything went well. We continued with the preparation of the spacecraft in the S1B clean room. The satellites were then transferred to the S3B fueling building, and we filled the 4 satellites. After filling, the satellites were integrated onto the dispenser to give what we call the stack. And the stack was then transferred to the final assembly building. It was integrated onto the launcher, and after the final inspection of the upper part, the full fairing was connected to the launch vehicle. On Tuesday, November 15, the launch vehicle, fully assembled, was rolled out from the final assembly building to the launch pad, and the final countdown operations began.
We are lifting 3.2 tons tonight with the 4 satellites and the new dispenser, which carries and separates them. That weighs over 400 kilos. The heavy lift Ariane 5 can orbit much more, you'll recall. It's the only commercial launcher on the market capable of lifting 20 tons. And the last time we used this version, it was for the 20-ton ATV, the Automated Transfer Vehicle, which took cargo to the International Space Station. That was 2 years ago. Many key people in mission control here, one of them the mission director you just saw, Thierry Villemar from Arianespace, working with Myrto Madelon, who is the Range Operations Manager, also called the DDO. It's his first mission in the role tonight. DDO from CNES, the French Space Agency, and he makes all the key announcements on the major milestones during...
À tous de DDO. Attention pour la séquence finale lanceur.
And during the countdown and during flight, and it's his voice you'll be hearing.
Top, H0 moins 7 minutes.
As he announces the 7-minute mark, which is a key moment in the countdown. The synchronized sequence, it's called, a complex series of operation running right down to liftoff, letting the launcher become autonomous, power passing from the ground, which controls everything now, to the 2 onboard computers, which will control everything afterward. The green status panels on the right of your screen are a summary of all the launch activities here at the base. We go when the satellites, the launcher, and the base are ready, and ready means green, and you see all is green now, so we're right where we should be. The green status panels include the launch system, which is the launcher and the pad, the range itself and all the services provided like telemetry, radar, safety, weather, the ground facilities, and all the rest. Over to Alexis Macaire of Arianespace now for a brief description of the mission today.
So we are located here in the station from which we will follow the flight. So the beginning of the flight will be followed by Galileo station here in this station. Then we will use the SNA, which is a boat located in the Atlantic Ocean. Then the Azores Islands, which are located also in the Atlantic Ocean. And then we will use New Norcia, which is located in Australia, to follow the final part of the flight. So this Ariane 5 flight is unusual in a way because we will target an MEO mission. The flight will target a northeast direction in order to reach the inclination of about 55 degrees. The satellites will be placed at an altitude of 24,000 kilometers, which is very close to the operational orbit for the Galileo spacecraft. The first part of the flight is a standard one. The atmospheric flight is performed by the EAP. And then, after the separation of the EAP, we will follow with the EPC flight, during which the fairing is separated. At the end of the EPC flight, which lasts about 10 minutes, we have the ignition of the upper stage, the EPS, for a first boost. So after the cutoff of the first boost of the EPS, we have a long ballistic phase which lasts about 3 hours in order to reach the altitude of the final targeted orbit for the spacecraft, 24,000 kilometers. So after this ballistic phase, we have a reignition of the EPS. We'll perform the second boost in order to reach a circular orbit for the spacecraft. After the second boost of the EPS, we'll start the final ballistic phase, during which we separate the spacecraft. So we will begin with the first pair of satellites, which will be separated. And after 20 minutes, we will separate the second pair of satellites. And from this event, we will start a passivation phase of the EPS, and that's the end of the mission.
This final 7-minute sequence is just the tip of the iceberg, actually. Final countdown on the launcher began 13 hours ago. At minus 10 hours, we had a check of all the electrical systems. On the satellite side, the Galileo teams began working 9.5 hours ago. And spacecraft countdown activities began about 40 minutes after that. A lot's still going on because the tanks are going to be pressurized for flight at minus 4 minutes. That has already happened or is still going on. And then at minus 1 minute, the launcher will be switched over to onboard power mode. Our cameras are here in Jupiter, but also at other places where people are hard at work today. One of these is the Launch Control Center. It's a very busy place, the launch zone, as you can imagine, where the launch management teams are working under the direction of the Launch Operations Manager, Klaus Zell, tonight. 2 teams are working up there. One is responsible for ground operations, the other for the readiness of the launch vehicle. The Launch Site Operations Manager heads up one group coordinating here with Mission Control in Jupiter for final authorization of the launch. When all conditions are right, he then okays the automatic sequence, which we saw, to begin at the 7-minute mark. In all, about 100 people working up there, going over the final checks and verifications on all parts of Ariane's launch system. They're closer to the pad than we are, too. We're about 15 kilometers away here in Jupiter. They're right up there, 3 kilometers from the launch pad. We've slipped just under the 2-minute mark. Here in Jupiter, the VIPs and the invited guests are making their way outside to watch the liftoff. If you haven't been down here, there are 2 either of Jupiter give a fine view onto the pad. If the skies are clear, and they are this morning, the visitors will have quite a sight. Here in Jupiter, you can see the operational teams, but in fact, to launch Ariane or Soyuz or Vega, we also need security, we need support from the Army, we need firefighters, journalists, and many, many other professions. The DDO is going to call out the 1-minute mark, and we will be into the final...
À tous de DDO. Attention pour H0 moins 1 minute.
And we'll be into the final 60 seconds.
Top. Moins 1 minute.
And there we are, final 60 seconds before liftoff of the Ariane 5 with 4 Galileo satellites. Give us a chance to say hello to our friends at Bremen, at Astrium Safran Launchers, to the Galileo teams, to the Kourou, Sinnemarie, and Cayenne sites here in French Guiana, to all our industrial partners, to everybody at ESA and CNES and all their offices, and to all of you following on the internet. We hope you all enjoy the broadcast. We're going to cut away and let you listen to the DDO as he calls out the final seconds, and we'll be back once Ariane has cleared the tower. Enjoy the liftoff, everybody. Final countdown coming up.
À tous de DDO. Attention pour le décompte final. 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage Vulcain. Allumage des UAP, décollage. Les paramètres de propulsion sont tous nominaux. La trajectoire est nominale, tous les paramètres en bord sont normaux.
Darting behind the clouds, in and out. Ariane 5 beginning her mission. Beautiful shots, lifting off at 10:06 local from the ground, roaring off the ground here in French Guiana, beginning her mission, the 9th for Arianespace this year, carrying the 4 new satellites in the Galileo constellation. Always impressive shots for the people here at Jupiter and on the beaches and at the observation sites, leaving her trail of smoke and fire. The 2 boosters providing 99% of the thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 760 tons was the mass at liftoff. She's burning 5 tons of fuel every second. Yes, that's every second. 2.5 tons burning in each booster per second. Plus the core stage, first stage burning another 300 kilos of fuel per second. Ariane 5 now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see. We are in the first of 4 flight phases, and we'll describe each in turn and in detail. So you can follow Ariane as she heads northeast across the Atlantic. Meanwhile, the DDO saying all well on board. Right now, the first flight phase, the single Vulcan core stage engine, and the 2 boosters are burning. The boosters are going to burn for another maybe 10 seconds, not even, and then you'll see them flame out and
Séparation des EAP.
And there they are, and the DDO has confirmed that. That's what it looks like up there. There's the second booster on the left out of camera range. The boosters fall 500 kilometers from shore in a protected area. You can see the shot there. The 2 boosters, if you can hold his camera steady. Well, we had 2 boosters on either side, and the main point of light was the core stage burning. Before the boosters are empty, their push diminishes, and the onboard computer senses the drop in acceleration and decides to separate them. On the bottom of your screen, our altitude on the left and our speed on the right. Altitude approaching 100 kilometers, and our speed 2.5 kilometers per second. Remember, we need to be between 8 and 9 kilometers per second to separate the satellites. We're coming up on separation of the fairing. That's in about 20 seconds from now. You can see in the animation the logo on the fairing that's placed there by the customer. Something of a tradition goes way back in the space business. A lot of people collect stickers and decals. The inside of the fairing lined with acoustic panels that protect the satellites from the noise, and there is a lot of noise, of the engines at liftoff.
Séparation de la coiffe.
And there's the separation of the fairing, and the DDO has called out right on time. You see there's one half on the left, the other half is falling out of camera range on the right this time. We can separate the fairing now because we're out of the dense layers of the atmosphere. We're over 100 kilometers up, as you can see on the bottom left of your screen. Neither friction nor heating, which could disturb the passenger, so we can get rid of the dead weight. We are into the second powered flight phase. The boosters have done their job. Only the single lower stage engine burning now. It'll burn for 9 minutes roughly. Our speed is important. That's the role of the main stage. Its cryogel propellant is not only highly efficient, but provides a push that can last for a long time. There are different propulsion systems you have noticed on the Ariane 5. Cryogenics, as used in the main stage, are more efficient than solid propellant, which is used in the boosters. Basically, and I'm no engineer, but I do know that solids are for getting us off the ground and away from the pull of the Earth, while cryogenics are more for precision orienting of a vehicle, and we'll see that later on with the upper stage. And of course, they allow the upper stage to be ignited in this version of the Ariane 5. Ariane 5, remember, is the heavy lift launcher. The 2 other members of the family, Soyuz, lifting middle-sized payloads, 2 and 3 tons, and Vega, the light lift vehicle for missions of 1 ton and under. shot of the downrange tracking station.
Acquisition de la télémesure lanceur par la
Alexis
station
Macaire.
navale
You see
Ariane.
Galileo in yellow is the station here, the tracking station in French Guiana, and you see the point of light where Ariane is right now. We're going to the first of what we hope will be several replay shots of liftoff that happened 6 minutes ago. You can relive those intense moments as Ariane 5 took off from the pad. We have cameras at several of the half-dozen observation sites that are stationed across the base, and they furnish us with shots from different angles. And here's another one from a little further back. We should have even more footage later on. The closest observation site is called Toucan. Some of you may have been out there. Many of the VIPs are there tonight, including Patrizia Secchi of ESA, who is going to be joining us here in the booth during the second part of the broadcast. We have been picked up by our downrange tracking station, the ship SNA, the Station Navale Atlantique. That's a ship designed specifically for Ariane missions. We have ground stations, but we also have this boat which can move around to follow the launchers, picking up its radar and telemetry signals. All of Ariane's trajectory, of course, being designed to be followed from the ground. The launcher is sending radar and telemetry constantly back down, and a network of these stations are keeping a constant watch on the health of her systems. Telemetry, you may be asking, what is it? We hear this word a lot. Well, telemetry is launch vehicle data, simply. Information on thousands, I would say 1,500 parameters, is being collected and transmitted to the ground stations every second by the two transmitters on board and the antennas outside. These include indicators of Ariane's health and performance in flight.
La trajectoire est nominale, tous les paramètres à bord sont normaux.
Everything is perfect on board, says the DDO. On the left is the flame of the core stage engine still burning, and the long gray tube, that's the lower stage, Above that, a white band is the upper stage, and you see the 4 satellites exposed to the elements now with their blue solar panels. They're exposed to the elements with the separation of the fairing. The telemetry which comes in is analyzed in real time. Customers get immediate information about their spacecraft, very important for them. Other data are analyzed after
Il reste moins de
the
30
flight
secondes de poussée de l'EPC.
to learn how the vehicle has performed. About 30 seconds left in the first stage burn, and you'll hear the DDO, and you'll see on the screen, the DDO will call out extinction, and you'll see the blue flame in our animation go out, and then the lower stage will be separated, and then watch out for the ignition of the upper stage. All that coming up. There's the
Extinction de l'EPC sur commande de guidage.
confirmation by the DDO,
Séparation
separation
EPC.
of the second stage, and we're waiting for ignition of the upper stage. There we go.
Allumage de l'EPS.
All confirmed by the DDO. These 3 orders given by the onboard computer in about 13 seconds. The separation, the lower stage after separation falls into the Pacific off the coast of
Tous les paramètres à
Peru.
bord sont normaux.
We're now in the 3rd powered flight phase. This is a first 11-minute burn for the upper stage. It'll burn until plus 19 minutes and 55 seconds. There will be another in the second part of the broadcast, about a 6-minute burn. With separation of the lower stage, Ariane 5 has used up all of its 175 tons of propellant, and she has now lost about 14,000 kilos of dry mass. Remember, we were originally 760 tons. All that's left of the composite are the 3 satellites, the upper stage, and the vehicle equipment bay. This is the 54th mission for ESA by Arianespace, and there are more in the launch manifest. 3 for the European Commission, carrying 9 spacecraft, 8 Galileo and 1 Sentinel-2B, as well as 4 other missions. A lot of ESA missions, EDRSC, that's part of the European Data Relay System. Bepi Colombo, Europe's first mission to Mercury, the James Webb Space Telescope with NASA, all those coming up. Arianespace, ESA missions. Nice shot of the 4 satellites as they await their separation time. With the ignition of the upper stage, or into the latter half of the mission, over to Paul Verhoef of ESA.
Kourou, French Guiana. At the European Spaceport, 4 new Galileo satellites are being prepared in their dedicated facilities. Soon, these satellites will become part of the ever-growing Galileo constellation. Until now, these satellites have all been launched 2 by 2 with the Soyuz rocket. This time, the 4 satellites will be on top of an Ariane 5.
So the uniqueness of this launch is that we start for the first time with an Ariane 5. That the Ariane 5 has been specifically modified. It is a specific version which is only going to be used for Galileo. On top of it, we have a so-called dispenser, which is a device to which the 4 satellites are hanging during the launch.
Once in space, this dispenser will release the 4 satellites into their orbits. It's the first time ESA is using this particular dispenser. This is a new challenge, and it's crucial that the satellites don't collide with each other after their release. With these satellites, the constellation will be far advanced, with 18 of the 24 satellites needed for a worldwide coverage in orbit. However, with the ground segment in place and the satellites already in orbit, the European Commission can declare the so-called initial services.
Well, at the moment, the general public is using GPS in their receivers, and GPS has a number of satellites which is still a bit of a problem in cities. So with the addition of Galileo satellites, the availability of positioning in cities will increase significantly. And this is what users will start noticing.
Even with Galileo truly becoming a reality, the work is far from done. The European Space Agency and the European Commission want to keep Galileo and EGNOS at the forefront of innovation and technology. The European Commission is thus studying potential evolutions of the systems within the Horizon 2020 program research activities, H2020, while ESA will ask its member states to support a new navigation innovation and support program called NAVISP.
So the future is particularly about how do we integrate satellite navigation from space together with terrestrial navigation on the one hand, and how do we integrate it, for example, with communication services or on the more technical side with Earth observation. These are challenges we see ahead of us, and we have started to work on that.
The new program will be discussed at ESA's ministerial conference next December in Switzerland. Today, satellite navigation is at everybody's fingertips, and many smartphone applications rely heavily on navigation signals for work, games, timing, etc. With Galileo, ESA is offering the public a robust and reliable service in Europe and beyond.
While you were watching that film, we were picked up by the tracking station in the Azores, Santa Maria it's called. There will be a slight loss of the telemetry signal today. Sometimes it happens. It's quite normal, nothing to worry about. What happens is the ground stations suffer a brief loss due to the launcher's position sometimes. Today there will be a signal loss between Santa Maria and New Norcia, the Australian station, probably of about half an hour. Again, it's quite normal, nothing to worry about, and we don't lose the information. On board. In the vehicle equipment bay is something called the Central Telemetry Unit, and inside that is something called mass memory. The exact times and durations of the signal launch are programmed into this unit, and the unit is then programmed to record the data it would normally be sending down to the stations on the ground. It is also programmed to start sending these data when the signal has returned. The EPS, the upper stage, still burning. Another 6 minutes to go, roughly, in this first burn. The job of the upper stage is to take the satellites to their injection point, position them for separation, and then release them into space. But on this mission, has a little different because it's taking them into a transfer orbit role, and we'll get back to that in a moment. Our next film on the European Commission, for whom the Galileo fleet is being deployed.
Galileo the state-of-the-art European system of orbiting satellites and ground stations that will provide positioning, navigation and timing anywhere on the globe. It is the joint effort of some 5,000 people in various European organizations.
In the late 90s, visionary European politicians understood the strategic importance for Europe to have its own satellite navigation system.
La décision prise aujourd'hui par le Conseil est une décision clé pour aboutir dans l'un des projets technologiques les plus ambitieux, ou pour ne pas dire le projet technologique le plus ambitieux au niveau européen.
Since then, European Union countries have worked together to design and build the system.
It was the European Parliament and the Council that asked the European Commission to manage Galileo's development.
My strategy is also very simple, built on what we have achieved. I will focus work in 3 areas: deploying the infrastructure, providing services as they come on stream, and establishing Galileo in the market.
Soon, anyone around the globe will be able to use the Galileo signals, free of charge, to find their position with unprecedented accuracy. And thanks to an agreement signed between the European Union and the United States of America, Galileo will work seamlessly with GPS.
When lives are at risk, Galileo will also aid search and rescue operations by accurately locating emergency distress beacons. Galileo will also provide secure navigation tools for European Union governments. This public regulated service can be used, for example, by the Coast Guard or the police.
In building Galileo, European industries have demonstrated their know-how and excellence in satellite navigation technologies. Over the next few years, as Galileo's capabilities grow, that excellence will be there for all to use, and by 2020, Galileo will be fully operational and provide continuous navigation services worldwide.
And to keep Europe ready for the future, work has already started on the next generation Galileo system, which will provide more features and even better accuracy.
Less than 2 minutes to go in this first upper stage burn. The EC plans to declare that initial services for the Galileo system will be available by the end of the year. And we'll have more on that when Patrizia Secchi of ESA joins us later on. This mission is for the European Commission, of course, and the EC is Arianespace's #1 institutional customer. Arianespace has other EC missions to be carried out by ESA, the European Space Agency, currently in its order book. These include Sentinel-2B, that will be launched next year, another part of the space segment of the big Copernicus program. And there will be further launches of satellites to complete the Galileo constellation with this version of the Ariane ES. Galileo in all, 30 satellites, I do believe, including some backups, to be ready, the full constellation to be ready roughly around 2020, I do believe. We're coming up on extinction of the upper stage. That's due in less than half a minute. Today's mission is the 281st for the Ariane family in all, and the 233rd of an Ariane vehicle. Tonight's satellites are the 544th, 45th, 46th, and 47th satellites launched by an Ariane since first operations began back in 1979. And they are the 411th through the 414th to be orbited by an Ariane 5 vehicle. We're waiting for confirmation of the cutoff of the first upper stage burn.
Première extinction de l'EPS sur commande de guidage.
And they're coming right on time, confirmed by the DDO. The powered flight phase of the upper stage
Les paramètres
ends
orbitaux sont nominaux.
when the onboard computer judges that the targeted orbit has been attained. So, with power shut down, our speed starts to drop. We move into the ballistics phase. We start to coast. If you just joined us, we're launching 4 new satellites in Europe's big Galileo constellation, the Global Satellite Navigation System. Tonight we're launching numbers 15 through 18. We're going to leave you in just a few moments, but before we go, we're going to go to, I think, another replay of liftoff, perhaps from another angle. Before we go, we're going to move into the coasting phase, also called a free-flying or the ballistics phase. What's happened is with the first burn of the upper stage, we've placed the configuration or the composite, and by that I mean what's left of the original ship. Here comes your replay. The satellites and the vehicle equipment bay. We've placed all them on the correct path toward a separation orbit. So between now and the second burn, which is coming up in about 3 hours, and we're going to leave you until then, the composite will be coasting. And then we will, another replay, and then we will ignite the upper stage for the second burn, and this will place the satellites in the correct orbit needed for separation. So again, just to recap, we have had successful functioning of the lower stage, successful first burn, first of 2 burns of the upper stage, and what we're going to do now is let the upper stage coast for about 2.5 hours, and we'll ignite the upper stage for the second burn, and then we'll have satellite separation. So we're going to leave you. In the meantime, you can watch the ballistics phase on the Ariane website, arianespace.com. We're leaving the broadcast for the moment, but the webcast will continue. So enjoy the break. We'll see you back here, same place, in about 2.5 hours at 13:31 local, 17:31 Europe. See you later.
Tous les paramètres à bord sont normaux. La phase balistique se déroule normalement.
And welcome back, everybody, to the launch for the final hour, which will include, of course, separation of the 4 satellites. Joshua Jampel here again. During the past 3 hours, while you were separated from us, what happened? Well, we launched on time at 10:06 local. The launcher performed flawlessly. The first stage and the second stage burn going very well. And we left you after extinction of the first upper stage. First upper stage burn at plus 1955. Since then, we have been coasting. But a lot has happened. When we left, remember, we were flying at about 1,200 kilometers altitude and a speed of about 8 kilometers per second. Take a look now at the bottom left of your screen where we are in altitude, how much we climb, and how much our speed has dropped. So all that's quite normal. We're approaching separation time. We had acquisition of the signal from Malindi in Kenya, as well as Dongara Perth and the North Sea sites in Australia. Ahead, don't go away, because we've got the second upper stage burn and separation of 4 satellites. That's the fairing separation, which we also had, and separation, all the milestones. There's the first upper stage burn. So up ahead will be the second stage burn. Now, we're very pleased to have with us Patrizia Secchi, who is, tell me if her title is right, if I got this right, Head of Product Assurance and Safety for Navigation Systems at ESA. Did I get that right?
That's correct. Thank you very much, Josh, for introducing me.
Welcome, and thank you for being here.
Thank you.
Now, Patricia, as Head of Safety and Product Assurance for Navigation Systems, we're going to be benefiting from her presence and experience talking all about Galileo, a lot of other things that we should know about the program. But for now, you just came back from Toucan, the Toucan site, where you watched the launch. How was it for you out there? Was it exciting?
Yeah, this was a fantastic experience, I have to say. So this launch has been really wonderful to watch. It was a beautiful sky, and we really, when we rose, we heard this roar. First you see a lot of light and a lot of gas, and then only a few seconds later you hear a lot of noise, really roaring.
The light comes first, and
the gas.
And then the sound. We'll get back with that. But the DDO has just said that the second stage burn has commenced.
Les paramètres de propulsion sont nominaux.
And he says everything is right on time. Now we're going to burn for about 7 minutes, and this is going to bring the composite to a circular separation orbit. So, Toucan, what impressed you the most? Was it the sound or the light or something else?
The sound was really impressive indeed. Compared to the Soyuz launch, it was so much more noise, and it really goes into your body, really. And then it was this incredible light. I mean, all the light coming below from the launcher, and I think there was the sun hitting on it. So watching at this, it was almost painful, but it was fantastic.
Very good.
And then the separation of the two solid boosters.
You saw them from...
I saw it very well, but it was fantastic. Yeah, these two little lights coming down.
Tous les paramètres de propulsion sont nominaux.
All right, we're going to leave the history of Toucan and look at our next film for more on the Ariane 5 upper stage.
From this desk, we monitor all the filling operations and the countdown for the EPS upper stage. This stage, with storable propellant, is used in this ES version of Ariane 5. This stage was used for the first Ariane 5 launches and for the ATV cargo missions to the International Space Station. The stage is assembled in Bremen and equipped with one Estes engine made by Airbus Safran launchers in Ottobrunn, also in Germany. It's powered by liquid propellant stored at temperature in two high-pressure tanks at 400 bars, and it's pressurized by gaseous helium. There's another version of the upper stage called the ESCA that runs on cryogenic fuel. This stage can store 10 tons of propellant in 4 tanks. The thrust of the Estes engine is close to 3 tons and lasts 320 seconds. This stage is less powerful than oxygen and hydrogen propellant, but it has advantages. The stage is lighter due to the pressurized gas propellant cycle. Storing fuel at ambient temperature lets us perform filling operations in the final assembly building before the launcher is rolled out to the launch zone. And the propellant is hypergolic, which means combustion occurs only when the two elements, hydrazine and nitrogen, come in contact. We don't need an igniter, like on the ESCA version, and we can reignite the engine several times. For this 4-hour mission, we've equipped the upper stage with a propellant heating system. It's used during the final countdown to raise the fuel temperature at liftoff and avoids its cooling down during the long ballistic phase later on between the first and second burn. After payload separation, the stage will be passivated, or emptied of its fuel, which will enable it to remain stable during its parking or cemetery orbit 300 kilometers below Galileo for as long as 100 years. So for all these reasons, the ease at which we can put the EPS stage into orbit, its simplified countdown, and the ability to reignite its engine, the Ariane 5 ES vehicle is the perfect launcher for this type of mission.
Back with Patricia Secchi of ESA. I want to ask you about what you do, but before, we have to talk about the French Guiana site, and it's for a reason. Do you know why the site, the launch base in French Guiana, was chosen?
Well, first of all, for its unique position so close to the equator. This makes launching so much easier and requires so much less what is called delta V to be able to launch a launcher and then a satellite in orbit. Second,
that's one of the reasons.
That's one of the reasons. Second, because it's French, so this was actually supposed to be the European spaceport.
Yeah.
So a European location outside of Europe in such a convenient location.
How about the ocean? We needed an opening on the ocean to be able to launch over uninhabited areas.
True, yes. So opening on the ocean, and also the fact that the population density is so low here,
right,
which makes it, of course, the risk associated with the possible launch failures lower.
Good. So you're doing really good. No hurricanes, no earthquakes also.
True. That's very good.
And a final thing, which brings us to the image on the screen, they needed hills, nearby hills. where radar and telemetry facilities can be installed. Now we have these here, and we brought the camera up there. This is called the CVI. It's right behind us here in Jupiter to the south. The CVI is the Quick Look Telemetry Display Control, another place where people are working very hard tonight. The buildings have all the means for receiving and processing and storing and analyzing the data as it comes in from the ground stations we've been talking about from the Ariane flight path. So you can see these people now are following and analyzing all the key flight data and reporting that information back to us here in Jupiter. Okay, I want to talk about your role now. What do you do? What do you do in a typical day, or what's your role with Galileo?
So, as I said, I'm the head of product assurance and safety for the Galileo, for the navigation systems, in fact. And so what we do, we are first of all responsible for quality, so for the quality of the systems, the satellite or the ground segments that we build. And this means that we check that everything has been done according to the procedures, that all the requirements are met, and this is the nice phase in the design.
So you're sort of a quality control office, is that fair to say?
It's called, you have first of all quality assurance in the first phase, so to make sure that you will have proper procedures to do everything properly, and then later on we control, with the quality control, that everything has been done properly. We also have some other disciplines, so we also control the selection of proper components for the satellites, which has to have a special characteristics,
Seconde extinction de l'EPS sur commande de guidage.
All right, the DDO has just called the extinction of the second upper stage burn, so everything proceeding right on schedule. Now, in about a minute, we're going to have separation of the first two satellites. What's going through your mind right now?
This is really the moment of truth, indeed. So this burn is actually the one which is going to circularize our orbit and make it really right, the orbit that we need. And then at separation, our satellites will go on, so they will become live. And then we will find out whether they are in the right orbit, whether they're working well, and we will have a serious, this is the most delicate phase in the life of the satellite.
Right now.
First 20 minutes. Right now, what's going to happen right after separation.
Okay, we're going to have separation of the first two, and then, what, 20 minutes later we have separation?
20 minutes later we're going to separate the other two. The reason to have this delay is because we don't want really the four satellites to collide once against each other, so we're doing it in pairs in different directions.
And you'll see that in just a few seconds. They're going to be launched. The pairs are diametrically opposed
exactly
from each other on the corners, and you'll see that on the animation, and that's, as Patricia said, to avoid collisions. That's the only reason? That's
in fact the only reason. Also, our LEOP teams, so our launch and early operation teams, they need time to be able to put the first two satellites into a safe area, safe position, and then we're going to do for the other two.
There's another reason to launch them diametrically opposed, I'm thinking, and that's if they launch
Galileo FOC-M6,
side by side. There's a balance problem.
I don't think this is an issue because you are in vacuum, so this is not going to be a problem. Except for the forces that, of course, you cause when you, indeed, you cause a reaction, a dynamic reaction when you move those satellites. And because they're moving them in opposite directions, then the balance is going to stay. Indeed, you're right. If we would release them both in the one direction, maybe the dispenser with the EPS would move into the other direction, and this would not be good.
Well, apparently we're okay. The first two satellites have been separated. The DDO has confirmed it. So that's the first good news. So the new dispenser we've been talking about has done the first half of its job. The second pair of satellites coming up in about 20 minutes. You want to talk about the dispenser?
Yes,
dispenser?
So the dispenser accommodates 4 satellites. It's a brand new development that has been developed to launch the 4 satellites on the Ariane 5. And all the satellites are attached into 4 points against the dispenser, and there are some very small pyrotechnic devices releasing the satellites at the moment of separation.
Pyrotechnic, that's like we saw with the fairing.
Yeah, it's like a small explosion, but very contained.
A small contained explosion, because there are some separation systems that use springs to push the satellites away from the mothership. It's a different system.
Yeah, this is different. We also have the so-called non-explosive actuators, which indeed do not do any small explosion. And now what is going to happen is that the 2 satellites, once they are released, there is an umbilical which is dropped away and switches the satellites on. And then the satellites will then come vital, and then they will receive some solicitations from the ground stations to start transmitting telemetry. And this is when we're going to be able to know that the satellites are alive and they can start their automatic safe sequence.
Okay, so that's the confirmation we're waiting for in about 20 minutes, for the first pair.
We have this very delicate phase now where after the switching on of the satellites, the first thing to do is to release the solar arrays because you need power. The satellites have a battery on board, but the battery has not an unlimited life, so at a certain point it needs to be recharged, and that's why it's essential that the solar array are deployed as quickly as possible.
Right, okay, that's another thing we have to check in 20 minutes, that the solar arrays come on. All right, back with more in a moment, but after this film, you will have known everything you've ever wanted to know about how Galileo works.
The 30 satellites orbiting the Earth are supported by a worldwide ground segment. 2 control centers process the navigation signals and maintain the constellation. They follow the satellites and send them commands through the telemetry and tracking stations. The satellite signals broadcast Galileo time as well as position information. These signals are received by the Galileo sensor stations, which transmit them to the control centers. All the navigation data is computed and uploaded to the satellites via the uplink stations. The ULS network is tasked with uplinking the data to the satellites. There are 5 ULS sites around the globe, 4 on the equator and 1 near the North Pole. Thanks to this ground segment, your receiver can calculate your position with pinpoint accuracy. Your navigation instrument calculates its distance from a Galileo satellite by measuring the time that the signal takes to reach it. With one satellite, you can be anywhere on a circle. But as the time of your device is not very precise, 4 satellites are required to calculate your exact position. 30 satellites are ideal to cover the whole world. Galileo allows many different applications. In the air, on the ground, and at sea.
Let's talk a little more about users now. Users will include anybody who needs ultra-precise data. That could be banks.
Everybody. So the Galileo services include the generation of an open signal, which will be available to everybody, everywhere in the world, and will be used for any type of navigation applications. In fact, nowadays, everything is based on the location of your position. So apart from the traditional NavSat systems and your navigation device on your phone, but it's even more like when you go, any website you go, doesn't even ask you that Google would like to know your location. I mean, this is also based on navigation. So it's really, it's becoming, and then you have a wide range of applications which can benefit from navigation information.
Okay, we'll be back with more with Patricia Secchi after our next film, which should be coming up, maybe not. Okay, well, so how do I use the system? I already have the. Do I have to download an application, or do I have to buy a new device? Or
well, you have to have a Galileo chip. So you have already a GPS chip on your phone. I'm sure about that. I
do.
Yeah, even if you don't know, but I'm sure you use Google Maps on your phone, do you?
I do use Google Maps.
And to use that, you need to have a GPS chip.
Really?
So, yeah, that's the way it works.
So in my phone, which is not a very elaborate, sophisticated phone, but it's a smartphone, it's the application is already in there.
The chip, the receiver. So this is a receiver of the GPS signal. And then what you're going to need to do is a receiver of the Galileo signal.
Okay.
And the chip manufacturers around the world are, of course, monitoring very closely the Galileo system to be then ready to put on the market the chips needed.
Okay, over to the CNES, French Space Agency, for more on Galileo.
Program designed to make Europe independent from the US GPS. A constellation of 30 satellites orbiting at an altitude of over 23,000 kilometers will offer accuracy to within a few meters. 14 satellites have already been orbited by 7 Russian Soyuz launchers from French Guiana. Initial services will start at the end of 2016 with the launch of 4 satellites by Europe's Ariane 5 launcher. This is an important and symbolic launch.
Il fait se rencontrer 2 programmes de souveraineté de l'Europe. Ariane 5, bien sûr, est le lanceur de souveraineté de l'Europe. Et Galileo, parce que Galileo, ça va permettre un positionnement indépendant aux citoyens européens. Et donc le fait que 4 satellites Galileo soient lancés par un lanceur Ariane, je crois que c'est vraiment l'exemple d'une Europe qui réussit et qui réussit bien.
The Galileo program is generating some 10,000 direct jobs in Europe. CNES was closely involved in the preparatory phases of Galileo and in defining signals.
Le CNES est l'un des rares acteurs qui a porté dès le début Galileo sur ses fonds baptismaux. Le lanceur Ariane 5 est spécifiquement adapté pour cette mission et notre direction des lanceurs a joué un rôle très important dans cette adaptation. Les 4 satellites vont être mis à poste grâce aux équipes du Centre spatial de Toulouse et le lancement, bien sûr, il est fait par nos équipes au Centre spatial guyanais. Donc le CNES est partout sur Galileo et sur ce lancement en particulier.
Full services are planned for 2020. Galileo will serve a wide range of professional and everyday applications, notably on our smartphones, and is set to generate a wealth of social economic spin-offs.
Now, we're talking about a navigation system. We're talking about the satellite side. That's the sexy side. But there's another part.
Yeah, this is, of course, the most appealing side, and it's what everybody sees, even at the European Space Agency. So we see the satellites, and this is a very prominent part, and of course, it's essential if you want to be able to broadcast a navigation signal. But without a ground segment, this would not be possible. So obviously, the ground segment is essential. And just to make it very, very simple, we have 2 essential parts of the ground segment. One part, which is the one which controls the satellites. So the satellites are controlled from ground and operated from ground.
Right.
And then we have a second part, which is really the part which generates the so-called navigation message, which is then uplinked to the satellites and then comes down and provides a navigation signal.
We're going to go to a film now on the services provided by Galileo once it's operational.
With each Galileo launch, Europe's independent satellite navigation system gets closer to delivering valuable services to users around the world. When Galileo moves from a system in testing to a live service, for the first time in history, operational global positioning, navigation and timing information will be provided by European satellites. And soon, we will be able to use Galileo without waiting for all satellites to be in orbit. Once all tests have been completed, Galileo initial services will become available. So how can Galileo provide services with a growing constellation? Today, almost 40% of receiver models are Galileo-enabled, and the first Galileo smartphone is on the market. Plus, most receivers already combine Galileo's open signal and GPS to make positioning more precise. This is especially important in cities where satellite signals can be blocked by tall buildings. More satellites in view means better availability and accuracy. Galileo initial services will also help save lives. Its search and rescue service will help operators respond to distress signals faster and more effectively. While Galileo is being built in space, much work is also being done to ensure that it delivers real benefits on Earth. The European GNSS Agency, or GSA, is tasked with this important job. The GSA is working with user groups, from app developers to chip and receiver manufacturers, to ensure that navigation devices are ready to harness the full potential of Galileo. The GSA is the European Union agency responsible for operations, service delivery and security of Europe's navigation systems, Galileo and EGNOS. Headquartered in Prague, with facilities in France, Spain, the Netherlands and the UK, the GSA was created to ensure that citizens get the most out of Europe's satellite navigation programs.
We are at the eve of a major transition where we will be moving from a deployment phase to an exploitation phase, and it is where the GSA is going to take a prominent role in the service provision area as well as on the security monitoring for the overall system. The GSA is ready to make Galileo work for Europe.
Et la GSA va assurer les opérations de Galileo, la sécurité du système et puis surtout mettre en place les applications qui vont faire que les citoyens européens vont se servir de Galileo.
Galileo, Europe's unique independent satellite system under civilian control, is ready to make its mark.
Ready to make its mark. The film mentioned initial services. What can you tell us about that?
Yeah, this is a very important moment in the history of Galileo because we are about to declare by the end of this year the so-called initial services. So the Galileo system is not yet fully deployed. However, we have already capability and we are able to provide already navigation signal. And this is what we're going to do. So we're going to declare that the service is available for users. The quality of the signal is already very high. So the accuracy is going to be very good. Only because we have a limited number of satellites, we are still not able to have a global coverage.
So by the end of the year, we can
This is yes, indeed. The Galileo signal is actually already available, and there are people around the world who have received that. But this is when, after the declaration of initial services, is when it's going to be available.
Okay, a word now from OHB, builders of the 4 Galileo satellites.
Galileo FOC, satellites by OHB. OHB headquarters Bremen, inside the Galileo cleanroom on Island 1, where the mechanical integration of the Galileo FOC satellite starts. The last satellite, Flight Model 22, has finished the first part of the mechanical integration and is now ready for the transfer to Island 2 for the first electrical tests. OHB colleagues in AIT are preparing the so-called marriage of Flight Model 18, which means payload meets platform. The modular and flexible design by OHB allows great flexibility in AIT, as well as at the same time it complies with ESA's high-quality standards. OHB's head of mechanical AIT for Galileo, Matthias Tausche, is responsible for all 22 satellites.
We have here in Bremen 7 islands. We have a mixture of mechanical and test islands. So we start with mechanical islands, go over to test islands until we reach our configuration here, what we want to reach in Bremen. And every 6 weeks we finalize one satellite.
Inside OHB's other clean room, the Galileo satellites are tested on system level before their shipment to Aztec in Nordwijk, where they undergo the environmental tests. By now, all FOC satellites, which have already been launched, show an excellent in-orbit performance. Parallel to the successful delivery of our FOC fleet, OHB is already actively working on the development of the next generation navigation satellites. Find out more about OHB as a leading space systems company in Europe on ohb.de. Galileo FOC, satellites by OHB.
The 4 satellites orbited today are the 11th, 12th, 13th, and 14th OHB-built satellites to be launched by Arianespace. 8 more are currently being built in Bremen. Now, for these 4 today, the first 2, 1 and 3, will be operational when?
By mid-April. So after the initial phase, the so-called LEO phase, there's going to be a phase which is called in-orbit testing, where we're going to test all the subsystems of the satellites and the clocks. And then we can declare the satellite operational. And this is going to happen by mid-April this year. And then for the second set, it's going to be around early June.
Okay, so there's that's coming up before you know it, right?
Yes, it's very quick indeed. So it takes about 3-4 months to do these operations and have them operational fully.
And as far as I understand, there will be about 80 CNES and ESA people. How many?
Ah, sorry. I thought you were talking about the number of satellites.
No. I'm talking about the number of people involved for getting the satellites ready. I heard 80 CNES and ESA people, but we'll be back with that. For now, a film on the satellite's early orbit phase maneuvers.
Following liftoff after about 4 hours, the first pair of satellites, FM7 and FM13, will be deployed by the launcher system. After 20 minutes, the second pair of satellites, FM12 and FM14, will also be released. Following the deployment from the launcher system, each satellite will switch on and perform a sequence of automatic operation, commanded by the onboard computer. This will include the switch on of the telemetry tracking and command transponder, allowing communication with the ground stations, the spacecraft attitude stabilization, the deployment of the solar arrays, and finally, the pointing of the spacecraft to the sun, allowing the recharge of the spacecraft batteries. The sequence will be closely followed by the Galileo Loop Control Center at CNES in Toulouse, France, through a number of dedicated ground stations. Following the initial startup sequence, the satellite will undergo a number of checks to confirm the good status of all the platform equipment. After approximately 6 days, the satellite will be commanded to slowly move to their assigned in-orbit slot using the satellite propulsion system. After approximately 3 to 4 weeks, the payloads of the first pair of satellites will be activated. The payload of the second pair of satellites will be activated 3 weeks later. After this payload activation, the in-orbit testing will start and will last for several weeks, aiming at characterizing the performance of the navigation payload and of the search and rescue payload. In the second half of April 2017, FM7 and FM13 will be declared operational, and FM12 and FM14 will reach the same status in the first half of June 2017. With these new satellites, the Galileo constellation performance and availability will further enhance and extend across the entire globe. Thank you.
We are awaiting confirmation of a separation of the final 2 satellites coming up in about 40 seconds. While we're waiting, anything to add to what Giuliano Gatti said about the operations?
Giuliano made a very accurate description of what's going to happen now with the satellites up until the declaration of being operational. Indeed, it is very good. And what is remarkable to say is that in particular this time, because we're going to have to operate 4 satellites at a time instead of 2 satellites, right. Yeah. This is of course the subject of very intense work, and it's been actually intense preparations. And we have a combined team in CNES now in our LEOP Operations Center, a combined team of people from ESA, and from CNES, who are going to be very busy in the next few days.
FOC-M6, SAT-16 et SAT-18.
All right, the DDO has just confirmed separation of the 2 last satellites, and you hear the applause.
This is really very good.
In the hall. So that's the first good news. I guess you can say that the new dispenser has pretty much done its job. We don't have 100% confirmation because we have to check, as you said before, that they're on the right orbit.
That's correct.
But the dispenser, which was there to carry and separate them, apparently
has worked correctly, indeed.
Okay, so the last 2 satellites are on their way. And now, as you said before, we have to wait again. We have to wait for confirmation of a few things on the satellites. Thierry, now I'm checking his watch there. You saw he's looking. How long do we have to wait? Probably another 20 minutes for separation.
Yes, so now we know that all 4 satellites have been released. So we have to wait to understand that all 4 satellites have correctly switched on. And most importantly, that they are, very importantly, that they are in the correct orbit from which we will be able to operate them.
So there's a couple of things we're waiting to confirm. that the dispenser has worked correctly. Okay, we've seen that. But 3 other things, as you mentioned, that the satellite has been separated in the right direction, the satellites, I should say. So we have to wait for a first assessment, I guess, to see that it's on the right orbit.
Indeed.
And that's coming in 20 minutes. Also, you haven't mentioned the solar panels. We have to check that they're on, right?
Yeah, we have to wait for the automatic sequence to have been completed so that we have the solar panels fully deployed, that we have the right pointing to the sun so that, as Juliana said, the batteries can charge, and that we have indeed an attitude control system which is provided the right attitude for the satellite.
The attitude, right. And the attitude means?
It means the positioning, basically, for the satellite.
Okay.
Orientation.
Okay, while we're waiting for these confirmations, we're going to go to another replay of the launch. This is from a closer angle, I do believe.
Signal for both. We have 5, so basically we have this 3 and this 3. Okay. Confirmation of right mode. So basically like this, and they are on. And with this light here, to watch, it was incredible. We have had separation of the final 2 satellites. Separation, of course, marking an end as well as a beginning, the end of the launch vehicle's mission, I guess, but just the start of life for your satellites. For the 4 new satellites.
Now, the satellites you mentioned were waiting for the confirmation of the signals and that they're on the right orbit and the solar panels and all. They are followed in this phase, which they call early post-separation period, by Toulouse. Right?
Yes.
That's the center called the Customer Early Orbit Phase Control Center in Toulouse. And Toulouse is using the ground stations who are going to receive the signal and get the information that we're waiting for and send it to Toulouse. Is that right? And then Toulouse sends it to us?
They have a net of ground stations, and the ground stations are right now tracking the satellite signals and assessing what is the orbit the satellites are on.
Okay, so these stations, I do believe there's one in Australia that's at Dongra near Perth. There's another one in the Kerguelen Islands in the Antarctic, and the last one is in South Africa. I can never say the name. You're going to help me.
Hartbeespoort.
Thank you very much. Hartbeespoort. So these stations are going to send the data to Toulouse, and Toulouse sends it to us. Is that how that works?
Yes, they're going to tell us whether the orbit is correct.
Okay, so that's what we're waiting for. Folks.
Later on, we will also receive a precise orbit determination from the launcher authorities, telling us exactly in which orbit the satellites are going to be positioned.
When you say launcher authorities?
Yeah, with the launcher, from the launcher people. So this will come only later.
Okay. Okay, we talked about LEOPS. What else did I want to ask you? I wanted to ask you about the qualifications that your office performed. Now, you're performing environmental?
Yes, well, it's correct. For each satellite, you have to demonstrate that the satellite, once you have completely assembled it and and is closed, that the satellite can survive the environment in which it's going to operate. And the environment comprises the environment on the launcher, and this is a very strong environment, as we've seen today. Lots of noise, which means acoustic vibrations.
A lot of shaking.
Lots of shaking. And then that the satellite will be able to survive in orbit where the major stresses are caused to the fact that it's in vacuum and that the temperature, because obviously since there is no movement or no air, basically if it's in the sun, very high temperature, when it's in the shadow, very low temperature. So in order to demonstrate that, there is a so-called phase which is called the satellite environmental testing, where all of this is demonstrated in a test center. In ESA we have a very, very large and very nice test center with all the facilities necessary to do that. And for this particular mission, the satellites were already qualified in the past for the Soyuz, but we had to perform a delta qualification.
Delta meaning?
Delta, an additional qualification to demonstrate that the satellite will also survive the mechanical stresses from the Ariane 5, which are slightly different from the stresses from the Soyuz launcher. So we did that, and this was successful. And on top of that, also the launcher had to be adapted. Both the fairing, the launcher system, and we had to develop a dedicated dispenser, and all of this was also properly qualified, and this happened a while ago.
Now, how does all this you see is properly qualified? That happens on the ground, obviously.
This happens on ground using dedicated facilities, like for the satellite to demonstrate that it resists on the vibration. It's put on a so-called shaker, which is the table which moves in various directions and literally shakes the satellite. And then to demonstrate that it will survive to all the noise produced by the launcher, it's put in a so-called acoustic facility, which generates the noise in the frequencies of the launcher.
And you're present at all these tests, or your office designs the tests?
Yes, so what the product assurance and safety team witnesses all these tests, and we make sure that the procedures are followed properly. And then if there are any issues with the test and there are any problems detected on the satellite, then non-conformance reports are recorded, and then we follow up until the correction of the issues which may be generated.
Sounds like an exciting job. I'm sure you love it.
It's very exciting, especially being close to the satellites is always very, very interesting.
We are waiting for Stefan Israel, Chairman and CEO of Arianespace, to come out from the fishbowl here and come out into the VIP section and confirm, hopefully, acquisition of the first 2 satellites. I do believe he should be coming up. That's one of the things that we're waiting for, and I think he's going to have the information that, as you mentioned, Patricia, comes from Australia and Antarctic.
Thank you. Kerguelen.
And then goes via Toulouse to us here.
Indeed.
So that's what we are waiting for. I can see Stefan Israel is standing and in the fishbowl. He's not yet come out. So we will continue our conversation. Now, one of the satellites, I don't know which one, but I was told has a radiation monitor. Is that right? Why is that important, and why only the satellites?
This is a very important instrument because one of the factors which determines the life of a satellite or any disturbance is its radiation. So there is a lot of radiation, of course, in vacuum, and this is caused by the sun. And all the electronics on the satellites are very sensitive to radiation. So it is very important to have a device like the radiation monitor, which monitors what are the level of radiations coming from the sun. And this is not only important for the Galileo satellites, but also for the whole scientific community. And in fact, we're going to spread this information to all the scientific community. Now, because this is not really is not really vital for the life of the satellite, you don't need to have one on each satellite. So we're going to have a total of 4. So we're going to spread them onto various satellites. But the information they provide is extremely important.
And you say providing information that'll be free to the public, I suppose?
Yes, this will be free to the public, available to the scientific community.
Okay. We're still waiting for Stefan Israel to come out. I think what we'll do is we'll cut away, and we'll be back with you once Stefan Israel's making his way to the podium. We'll give you a break from us. We'll be back very, very shortly. Well, Stefan Israel is out of his seat, and he is making his way. He's talking, I think it's Paul Verhoef he's speaking with, Director of Navigation Programs. So they're getting their information together. While we're waiting for him, we can look over the history of the Galileo program. Now, in order, which came first? The Jove A and B satellites came first, is that right?
Correct. These were the first two Galileo experimental satellites, which were launched respectively in 2005 and 2008.
From Baikonur?
From Baikonur.
Not from here. That's before Soyuz came to French
Guiana. Kourou, yes. There was still launched with the Soyuz, but from Baikonur indeed. And these were the satellites with which we demonstrated that we could use the frequencies, and we also had on board the clocks that we're actually using on the operational satellites to demonstrate that they were working properly.
That's an important point, the atomic clocks, right? Because that's something that's very, very new on the Galileo system.
Correct,
I
yes.
do recall.
We have two types of clocks on Galileo. We have the so-called rubidium clocks, and we have the atomic clocks, the maser, the so-called masers. And those are very, very precise clocks, which actually are flying for the first time.
And the rubidium clocks, how does that differ from the atomic clocks?
It's a different type of generation of this very precise signal which is needed for navigation. And of course, I mean, when we talk about atomic clocks, we have to understand that it has nothing to do with nuclear energy or atomic explosions. This is very non-dangerous. So it is just that it uses the atomic frequency, certain atomic frequency, to produce a very precise clock signal.
Okay, that's Jove A and B. After that, we had what they call the IOV
Yes, we had the in-orbit validation
in-orbit
satellites.
validation.
Yeah, 4 satellites. So 4 in-orbit validation satellites, which are in fact fully operational, also designed for a lifetime of 12 years. Yeah. And they were launched respectively. They were launched in pair from Kourou. In fact, this was the very first launch of Soyuz from Kourou, the first 2 IOV satellites.
2011, I think.
In 2011, yes, 21st of October 2011. I was there. I had just joined the project a few months. Oh. And I was in the LEOP team at the time, so I joined from there.
That must have been an exciting launch.
Very, very exciting, because it was the very first time we were launching from Kourou, actually, and the very first 2 IOV satellites. And we used those 4 satellites for the so-called in-orbit validation of the Galileo system. The 4 satellites are still in orbit and still working. We are only in 2016, so they've been working respectively for 5 and 4 years.
And their lifetime is 12?
It's 12 years, yes.
So we had the Jove, which was the precursor, which were the experimental satellites.
Jove A is still working today. It's used by the Satellite Prime, the manufacturer, which is SSTL in the UK, and they're still using it for experimental purposes and measurements. While Jove B, when it finished its lifetime, we actually retired it, so we put it into a graveyard orbit after full passivation, which means after completely switching off the satellites and making sure that there were no dangerous elements like fuel or batteries which could actually explode and cause debris.
You mentioned SSTL, that's the University of Surrey people who delivered the payload, also on tonight's satellites.
Yes, it's a company based in Surrey, and in fact they are responsible for the development of the Galileo payload for the FOC satellites as well.
All right, so then we move to the series of Galileo called FOC, or Full Operational Capability Satellites. And we had those launched when? 2 years ago.
Yeah,
right?
So this is comprised of 2 sets of satellites, both manufactured by OHB Systems in Bremen. And the first set is of 14 satellites, and today we are launching the 4 last of the first so-called batch.
Of the first batch, that's right, there are 2 batches.
Yes, indeed. A batch of 14 satellites, which was started in 2010, and a batch of 8 satellites, which we kicked off a bit later. So with today, the first batch is being fully deployed, and this is in a time span of 6 years, which in fact for an average satellite system is really good.
That's pretty good. So when they say the full system deployment is going to be 30 through those satellites, that includes backups?
Includes satellite spares, so you need to have an orbit with the operational satellites and extra satellites already positioned in the right slots, which can actually enter into operation when you have any failure of another satellite. This is essential if you want to have a system which operates continuously. You need contingency.
Okay, so that gives us a good picture of where we are. With the satellites tonight, we've launched 18 in the fleet, so we're more than halfway to full deployment. So Arianespace will continue to deploy the constellation. The next 8 satellites that you mentioned, Patrizia, are set to go on 2 more Ariane 5 launches next year and in 2018, just like tonight's launch.
Exactly.
With 4. They're aiming for August of next year and March of 2018. So Ariane 5 is taking over from the Soyuz.
At the moment, yes. But later on, we may use the Soyuz again, depending if you have to put spares in orbit. Maybe you don't need to put 4 at a time, so we may go back to the Soyuz. Who knows?
Okay. Tell us the differences now between this system, Galileo, and other existing systems. The Americans have GPS, there's a Russian system, there's a Chinese system. What's new, what's unique about Galileo?
The Galileo system is supposed to provide, I guess, a navigation signal of higher precision. So, and this is very important. I think it was seen also in the film where it was shown that, for example, the current GPS has problems in urban areas with very tall buildings.
That's right.
It's what they call the urban canyon. And hopefully with the satellites in orbit, more satellites in orbit, this can be solved. And also the Galileo signal is supposed to have a very high precision. On top of that, we have additional services. We have the so-called search and rescue service with the transponder on the satellite, which is supposed then to actually give information on area or people in distress having a search and rescue receiver. And then we have also the public regulated signal, which is a very precise signal for actually governmental authorities.
All right, before we cut away again and wait for Stefan Israel, sum up for us, give us a resume. What are the 3 or the 4 most important things that people should know about Galileo?
Well, first of all, Galileo is a full European system. So it's the European navigation system for the European citizen.
European independence.
European independence, if you want. GPS, it is publicly available indeed, but and Galileo will also be publicly available. Also, Galileo is not a military system. GPS was started as a military system.
Oh, well, I didn't know that. Yeah?
Yes, this is true. So this is really fully civilian system,
right,
which may be used, of course, for a variety of purposes, but it's not been conceived as a military system. It's navigation, and navigation is becoming nowadays actually widely used for a very range of varieties and applications of all type in the world. So this is will probably become more and more all of those applications based on navigation. So this is really important. And the precision of the Galileo system, because obviously if you build a new system, you try to do it better. If you do a copy of an existing system, I mean, right, this is not. What's the point, and where is the innovation?
So you have innovation, you have maybe new technology also?
Yes, indeed, also those masses are indeed a very new technology. And obviously you have to take some risk, and you have to prove that it works. This is clear. But this is why we're there.
Okay, we're going to wait again for Stefan Israel for confirmation. Just before we go, one curious statistic, maybe 2 if you'll allow me. This year for Arianespace, we've launched 6 times in under 4 months. The period from August 24th to December 20th, including upcoming launches, of course. August 24th was Arianespace Flight 232. That was the Intelsat charter. I don't know if you were here for that one. December 20th will be the last of this year, Flight 234, another dual commercial launch. So that run of 6 launches in 4 months includes 4 Arianes and 2 Vegas. Now the curious statistic is that's this year. Last year we had 6 launches in less than 4 months, same thing, in the exact same time period, from August 20th to December 17th. That was Flight 225 through to the Soyuz Flight 13, which was another Galileo flight on Soyuz. That run last year, 6 launches under 4 months, included 3 Arianes, 2 Soyuz, and 1 Vega mission. All that to say, all those numbers, to say that the launch rhythm here at the space remains very high, very intense in the latter part of the year, just like last year, and is a record for the Ariane family. Voilà.
This is an exceptional sequence, actually, of lots of launches. And also Galileo, last time we launched 3 times with the Soyuz.
That's
so
right.
This is really exceptional.
All right, we're going to give you a break. We'll be back maybe in a minute or 2 when Stefan Israel comes back for confirmation of separation, acquisition, and first operations of the 2 satellites. We'll be back in a moment. Well, as you hear and as you see, we have had successful confirmation of everything we've been waiting for. The signals and the right orbits and the solar panels, apparently, all is in order because there are a lot of happy faces and a lot of hugs and handshakes going on down there. So we didn't have the word from Stefan Israel, but we have the confirmation none the same. What's your reaction?
This looks like a very emotional moment right now. I think everybody's really happy. Of course, we're still waiting for final confirmation, but it looks like everybody's celebrating, and this is really such a great moment. I mean, this, if you want, I mean, this was the very first launch with an Ariane 5 going so high in such a high orbit and positioning the Galileo satellites. It's never been done before, and no matter how much you want to study this on ground, as long as you don't demonstrate it, you don't know it. And today we can say this went all right. This is really great.
So we are waiting now for the traditional post-launch speeches. You'll be hearing first from Stefan Israel.
So, dear Vice President Maros Sefcovic, dear Commissioner Bienkowska, dear Minister Schirer, dear partners, customers, ladies and gentlemen, distinguished guests, Arianespace is delighted to confirm that the 4 Galileo satellites have been safely separated on their targeted medium Earth orbits. The pointing of Galileo ground station antennas towards the payload is nominal, so is the deployment of the solar panels. Antoniana, Lisa, Kimberley, and Tijmen are the 15th to 18th Galileo spacecraft to be orbited by Arianespace. They will soon join their teammates in the constellation to provide Galileo initial services by end of the year. The use of the Ariane 5 ES version today, enabling the launch of 4 Galileo satellites at one time, allows us to maintain the pace we achieved last year in deploying the constellation. I must say that even if today all seems to have been very easy, it is a bit more complex because what has been done today by all the teams is the result of years of work. And I wish to thank the integrated ESA, CNES, ISL, Arianespace, OHB team, led by Inspector General Tony Tolker-Nielsen. We call him TTN, I think it's just here, because Tony has made a tremendous job, and we want to thank all the partners, and Tony especially, for this achievement. And you will allow me to thank, on behalf of all Arianespace team, Olivier Ricoire, who is at the CDL and who, for Arianespace, has made a very good job as well. I must say that in the room we have very important people, but we have also people who used to play a key role in this story. I think to two people, Jean-Jacques Dordain, former ESA DG, and Yannick Descata. And I know that both of you have played an instrumental role to go for these solutions in complement to Soyuz. So thank you very much to both of you as well. In 2017 and 18, 2 more Ariane 5 ES will continue the job, leading to 26 Galileo satellites in orbit and full operation of the constellation. So I want to express my gratitude to Vice President Maros Sefcovic, as well to Commissioner Bienkowska, who honor us with their presence this afternoon, for EC and DG Growth's continuous trust in Arianespace. Let me also thank the European Space Agency, our long-standing partner in charge of the Galileo space segment, and as such, our direct customer for this launch. We have with us in Jupiter Paul Verhoff, ESA Galileo and Navigation Director. We have with us Didier Fèvre, former ESA Galileo and Navigation Director. And we have Jan Werner in Baikonur, who is now waiting for a new success for space, for European space with Thomas Pesquet, and who has followed carefully this launch. So to all of you, to all ESA teams, thank you very much. I wish now to congratulate OHB for the on-time delivery of the 4 Galileo payloads, bringing to 14 the number of OHB satellites launched by Arianespace. We have Marco Fuchs with us. Thank you very much, Marco, for being with us. Ladies and gentlemen, this 9th flight of the year at the CSG marks the 75th successful launch in a row for Ariane 5. Last launch, we have done the same work Ariane 4 did with 74 success, and now with this 75th success, we have done one more, so it means that we have now overcome the record of Ariane 4. I want to congratulate all Ariane partners for this outstanding track record. ESA and all member states of the Ariane program, whose support is tremendous. Airbus Safran Launchers, Ariane 5 Prime and first shareholder of Arianespace. We have with us Alain Charmeau. Thank you, Alain, to be with us for this key moment. CNES, both qualification authority for Ariane 5 and our daily partner here in CSG, and for sure, all our contractors in French Guiana and all employees at the launch facility. And doing so, I wish not to forget my team, Arianespace colleagues. Your professionalism and involvement are key in pursuing the fabulous story of Ariane. Before yielding the floor to our customers and partners, I wish to highlight the fact that today, success comes after 2 key recent milestones for the future of European launchers. The EC space strategy, which has given a clear signal in favor of Ariane 6 and Vega C. The signature of the Ariane 6 contract on November 9th at ESA HQ. And I must say that we have in the room many players responsible for these both achievements, which are with us in Jupiter room. So thanks to all of them and congratulations to Europe. So, vive l'Europe and bravo pour ce magnifique succès. Merci beaucoup.
dear Stefan, bravo, congratulations, dear Elżbieta, my dear colleague from the Commission, dear Minister from Bavaria, dear Franz Josef, and I would say the dear European space family. We are very glad that you invited us. I hope that we can now officially declare that we brought you luck. And we are very, very proud of the achievement of today, because I know that these are years of hard work, and I really would like to thank all the European space family, Arianespace, CNES, the Space Center here, the French authorities, and of course the authorities of the French Guiana, our colleagues from European Space Agency, from OHB, from GSA, and of course from all the member states who are supporting the European space strategy, but also the member states who are member of the European Space Agency. Today, it's really a very important occasion, because it's a first launch after we adopted the European space strategy, which I believe is charting forward to make sure that Europe will be this very important global player, that we would be very influential in this geostrategic sector which the space is, and that we will show to our citizens what the space, what the new technologies could do for them. So to conclude, I just would like to have one more small wish. The Christmas are coming, so if you really would like to give a good Christmas present to our citizens in Europe, let's make the initial services starting just before that. Thank you very much. Congratulations.
Dear Maros, dear Stefan, Minister, ladies and gentlemen, dear colleagues and friends, if I may say like this, it's my second time in Kourou participating in launching. But this is really important today, because for the first time we have the 4 European navigation satellites in space launched, but the European launcher. This is an important moment that it was worth waiting, this, I don't know, 5 hours or something, to be sure about it. Of course, behind the success of today's launch, there are thousands of people, you name them, across Europe working as a one team. I would like, of course, to thank ESA, Arianespace, OHB, and its suppliers for their efforts. I am also very, very grateful to CNES and the French authorities. When the Commission decided to buy 3 Ariane 5 launchers and to invest €500 million in this, it was not only to accelerate our Galileo deployment, but it was also an important element of our autonomous access to space. To that end, we will continue supporting the development of the cost-effective, reliable, and competitive European launchers. Of course, I mean Ariane 6 and Vega C, because they will be crucial for Europe. And autonomy is also an important part of our newly adopted space strategy just 3 weeks ago. The strategy that sets out really the priorities, the route that will take over in the next 10, 15 years. This is the first time that Europe has such a document, such a strategy. Many challenges are still ahead. Galileo is essential to meet these challenges. We must ensure that our space programs better meet users' needs and new needs, also in particular security. My intention, Maros declared it before Christmas time, but I will be a little bit more careful. So I want to declare Galileo initial services operational as soon as possible. We are working hard on this. I know that all of you, together with the European Commission, we are working hard on this. I believe we can make it happen, even as a present under the Christmas tree, but I'm not, solving this now. We must also continue our efforts to complete the constellation. And just a few last words. As anywhere, cooperation by all European space players is really a determining success factor. Space is a very positive, I keep repeating this, very positive and very concrete example of what we can do together in Europe, because no single European country can do it and can do it on its own. We can be truly proud of what we have achieved today, but I think what we have achieved so far, and we need to build from now on, being based on our space strategy. Thank you very much.
Good morning, good afternoon, everybody. I lost a bit of track of time here. These are 4 small satellites here. I will tell you in a minute what this is. This is a great moment, as always. We are always relieved after months of work that it is all worked, that it is doing, as Marco said last night. There's always a bit of a risk, so we are always a bit anxious to see what happens, but great stuff today. I will not make it long. I want to thank in particular our partners in industry, our colleagues from Arianespace, from the Commission, GSA, from CNES. Nevertheless, there is something special today, particularly for them. 75th successful launch. We have felt from the ESA Navigation Department that because we are one of your big customers, Stefan, that we needed to do something to remember this. So I have here a little present for Stefan. You can open it up. I have the same present for the colleagues from CNES Launchers. Maybe Joel can take this for me.
Maybe we should come all together.
Yeah, exactly. One for CNES CSG, Didier is there. And one for, of course, for my colleague and friend Danielle, ESA Launcher team. Of course, behind it there is also industry. But we felt that the 75th success needed a bit more than only a few words.
So I disclose it.
You disclose it. You need to disclose it.
We now disclose.
Otherwise, the authorities will make our lives difficult. Good. Thank you, everybody, also from my side. And we hope to see you again all very soon for the next one.
Well, Vice President, Commissioner, Minister, ladies and gentlemen, the CNES, of course, is very happy to be associated with this extraordinary success this afternoon. A success for Galileo, the initial service for Christmas, for the Epiphany, I don't know, but as soon as possible, you said. It's nevertheless an incredible step that we've taken. 75 successes for Ariane 5. I mean, there are a number of people here who know the history of Ariane 5, and they're particularly relieved today. Which doesn't mean we don't have to prepare for the future, Stefan reminded us this morning, earlier on. And we decided on Ariane 6. Recently, the agreement's been signed. We're on the right path. Some of you saw the ELA-4 launch pad, which is being built here at the CSG, which will be for Ariane 6. So a new success for the European Spaceport, which is an incredible asset. So if we put all that together, Vice President, Commissioner, I think that all of us together is the strategic autonomy of Europe, the independence of Europe. And this is what you have confirmed today in a recent confirmation that you published just a few days ago. Thank you very much for having done it. I think it's important for the whole space community and for the whole of Europe that we represent here. Now we've got new phases, new steps. We've presented, it's got the ministerial conference of ESA in a few weeks' time. So another boost forward, preparation of this conference. Thank you all the teams from the Commission, from ESA, from the CNES, from the industry, the SL, from the base, who I know well personally, having lived a few years here, who've done this wonderful job. So we can confirm, as Stefan said, that through the positioning of Galileo with the CNES and ESA in Toulouse, everything is perfectly nominal, and so we are absolutely on the right path. So thank you and congratulations once again. Bravo.
Dear Commissioner Bienkowska, dear Vice President Šefčovič, lieber Herr Staatssekretär Pschira, of course, for the industrial satellite team, the OHB SSTL team, this is a very big moment, and I'm very, very happy to celebrate this with you now. My first thanks go out to Arianespace, another perfect mission, another very, very safe mission to the designed orbit. Of course, this was possible because ASL has provided a perfect launcher and a modified launcher to a certain extent that worked very well. Thank you very much. Thanks go out, of course, to ESA for the guidance and actually also the friendship of the ESA team to the industrial team and the whole EC team helping us and putting trust in the satellite industry. Of course, a special thank goes out to the OHB team now gathering together in Bremen. I know that there are people celebrating now, but also a very special thank to our SSTL teams, our friends in Guildford. I understand that you're also celebrating, and I think it's a big success for both industrial teams because today's successful launch completes the Work Order 1 contract. The first 14 satellites have been now successfly put in orbit.
de DDO, fin de la chronologie vol VA233, les moyens sont remis à la disposition des adjoints.
Signed the contract
Débriefage
in early
du
2010,
lancement en salle Max
and today, for the last 6 years, the satellites have been developed, have been built and tested, and now today that goes to a close, which is a very big success for both companies. Of course, for OHB, this has been a big opportunity, a big challenge. It has been a major success so far. And the trust and the confidence that was put into OHB at that time was enormous. So my real big thanks go out to the people that at that time, 6 years ago, were supporting the selection of OHB, supporting the trust into the industrial OHB SSTL team. I can guarantee you that we always felt that burden, we always felt that challenge, and we are very happy now to stand here and on behalf of Pat Wood and myself that we have been able to deliver on that. Yeah, the next satellites have already been accepted. The acceptance review was just a few days ago for the first satellites of Work Order 2. 3 more satellites from Work Order 2 are now at Nordwijk test facilities. Actually, only 3 are left in Bremen for manufacturing. So, of course, industry is ready for new challenges. Industry is ready for new work to come in our direction. And I can tell you that for the team, for the whole supply chain, it has been a marvelous adventure. We would like to, of course, conclude this thanks with the best wishes for our new members of the Galileo constellation, our new kids in the sky, Antoniana, Kimberly, Tiemen, and Lisa. They are on their way. I hope they will have a safe journey. Of course, I hope they have a bright future. And of course, I hope they have a long life out there supporting 500 million Europeans and the rest of the world with navigation services over the next 10, 12, 15 years. So again, thank you very much. And we hope that the early services really will materialize before Christmas, and we have new devices to put on everybody's, under everybody's Christmas tree. Thank you very much.
So, ladies and gentlemen, so again, congratulations to all of you for this outstanding success. I want to add one thing, the fact that this launch is very German because the 4 satellites have been made in Germany, but also the Aestus, the engine of the upper stage, and I think it's important to have that in mind. We are all European, but sometimes one nation is contributing more, and today we must say that Germany has contributed a lot. We are all European, but if I mention the fact, we have also a contribution from SSTL, more in the UK, whose shareholder is Airbus Defence and Space, and we have with us Nicolas Chamussi, who is the CEO of Space System. Okay, so just to conclude, we will be back in CSG on December the 5th for the launch, which will be with Vega. It will be the 8th launch of Vega. Vega is under the prime contractor of Avio, strong partner of Arianespace. We will launch Göktürk 1A for Telespazio and for the benefit of the Turkish government. So see you in December, and we will have a last Ariane, 20th of December, and after we will have initial services just for Christmas. Thank you very much.
That will do it for us from Kourou. Any last words, Patricia Secchi?
Yes, indeed. I think everybody has already thanked all the industrial teams and all the commission and all the people who've made this possible. But from my side, I really want to thank the ESA Galileo project team and my team, because without them, nothing of this will be possible. And thank you for your hard work and dedication. And let's celebrate.
All right, 75 straight for the Ariane 5, beating the old record of 74 set by Ariane 4 in 2003. Don't forget, at 17:20 Kourou time, that's 21:20 Europe, French astronaut Thomas Pesquet lifts off from Baikonur on a Soyuz for the International Space Station. So 4 new Galileo satellites on their way, orbited by an Ariane 5 for the first time. Our next launch, December 5th, that's Vega. We will be here, and we hope you will be too. Until then, on behalf of everybody here at the Space Center, Joshua Jampa with my friend Patricia Secchi, saying thank you for being with us. We hope you enjoyed it, and we look forward to being with you next time. Goodbye, everybody.
And thanks to you, Josh.